Hello everyone, my name is Litao and today I will be sharing our project Ivie, lightweight anchored explanations for just generated code. Imagine you are writing a bit of data analysis code and you don't know how to proceed. Then your AI programming assistant suggests this line of code. Does this do the right thing? You are not sure. What does the how argument do? Or surfaces? Ivie explains the suggested code to help you understand it. It explains what the how argument does by describing that it returns all rows from df_all while matching rows from df_apple. And it does the same for all of the arguments and the function as well. This is enough for you to know that the suggested code is doing the right thing. So, this is Ivie, or instantly visible in-situ explanations. Now, let me briefly talk about the way to work. The motivation for Ivie is that programming assistants like Copilot have taken the effort that programmers have normally spent writing code and transforming it into the effort required to read and understand the generated code. This has led to an experience where programmers have described understanding less about the code and where code suggestions can leave them lost in the sauce, discombobulated, and distracted by everything the programming assistant is throwing at them. This led us to ask if AI tools could help programmers understand code suggestions. Ivie offers two levels of explanations. For a single-line suggestion, Ivie generates explanations of the expressions that make up those suggestions, like so. In this example, the explanation describes both the function that is code and its arguments. For instance, Ivie explains parameter how by stating its behavior, that is, makes the merge return all rows from df_all with matching rows from df_apple, and also describing other important details like how it fills in not the number values where no match is found between the data frames. Ivie improves different kinds of explanations where a suggestion contains multiple lines of code. For instance, for this longer suggestion, Ivie detects major blocks of logic and explains the high-level behavior of each one to help the programmers orient to the code. For instance, the first line is described as creating a figure with two vertical subplots. These explanations could help a programmer get the gist of the code. For example, it could help them understand the big chunks of code in the middle, where the programmers may attempt to read this code as manipulating two axes, when in fact, it is manipulating the top and the bottom plots, which are referred to with the idiomatic name x. The design of Ivie's explanation was highly tuned. We anticipate they would be the most useful if explanations were anchored. That is, they appear in situ next to the code, so as to not divert the programmer's attention. Furthermore, they should be lightweight, brief, straightforward, and quick to read. Explanations should also be easy to invoke, appeared without any effort in the default cases. Easy to dismiss, in that they disappear as soon as the programmer clicks away, and accessible anytime. Programmers can request for explanations to reappear when they need them again. Ivie was tuned to satisfy these goals. We aim for a straightforward implementation that will enable Ivie to be more easily integrated into existing development tools. Ivie is currently implemented as a fork to the widely used VS Code editor. Its backend works like this. The programmer is in a code editor. When Copilot generates a suggestion, at this point, we query a large language model, asking it first to split up the code suggestion into expressions and then explain each of those expressions separately. Then, given the code suggestion in the editor, Ivie wraps up the explanations into labels, annotates the expressions that were explained, and then aligns the explanations with the expressions they explain. This is how Ivie explains a suggestion. To understand Ivie's effect on understanding code suggestion, we conducted a study. The study is designed to answer the following questions. First, does Ivie improve understanding of generated code? Second, does Ivie influence how much attention programmers give to generated code? And third, how distracting is Ivie? And finally, how does Ivie compare to chat-based AI code comprehension aids? Our study involves 32 programmers. Most were graduate student programmers. 31% had previously used Copilot, and all of them had previously used a chat AI like ChatGPT. Our study began with timed programming tasks. Like this one, each task required participants to interact with a code suggestion with an unfamiliar API. In both cases, a function from OpenCV library. The specific task involved taking an input image, doing some image processing on it, and then returning the processed image. Then, after all programming tasks, the programmers were surprised with a comprehension assignment, asking them about the API had been generated during the task. The comprehension assignment consists of questions like this, where programmers had asked to report the meaning of argument or functions. To determine the effect of Ivie, one of the programming tasks involved Ivie and the other involved a strong baseline. The baseline allowed programmers to select code and request an explanation of it, which could appear in a side window in the editor. Participants could also ask questions about the code in the chat pane. This baseline was designed to closely resemble the GitHub Copilot X in-editor chat, a production AI help-seeking tool. After participants had done the two tasks, one with a baseline, one with Ivie, and the comprehension assignments, they did an open-ended exploratory programming task with Ivie and the library they had not seen before. Then, finally, they completed a questionnaire and spoke with us about their experience. So, what was the effect of Ivie? Our finding was that Ivie improved code understanding. Participants also answered comprehension questions significantly more correctly with tasks they had complete with Ivie than with baseline. Participants also answered comprehension questions significantly faster with Ivie than with the baseline. Our second finding was that Ivie also wasn't too distracting. We asked the participant about the task load using 5 dimensions from NASA TRX. This chart shows their responses, with the y-axis represents agreement, where the lower is better. Participants report moderate load with the baseline and significantly lower load with Ivie. Our third finding was a crystallization of Ivie's value. Participants appreciate Ivie's conciseness and anchored nature of the explanations, and making the explanations easier to understand, simpler, and less overwhelming. The benefits of the chat baseline were its support for acquiring conceptual understanding of the task and deciding what code to write, the level of detail in explanations, and the ability to ask follow-up clarification questions. This suggests that perhaps both forms of AI support have a place together in future help-seeking tooling for programmers. Going back to our design goals from before, participants suggest 3 additional extensions to Ivie. Specifically, some wished for the ability to expand the explanation with more details. Others wanted for explanations to be adapted to them. For instance, if they knew the expressions that were being explained, they thought they may prefer less explanation. And others wanted a new way of controlling explanations. For instance, perhaps they could be allowed to select specific expressions to see explanations for them. This was seen as a desirable extension to Ivie. In summary, we developed Ivie to provide anchored, lightweight, AI-generated explanation to help programmers understand generated code. In our user study, Ivie led to better code comprehension and reduced task load compared to a chat AI baseline. And finally, we propose to improve Ivie by making explanations expandable, adaptable, and controllable. If you want to learn more about Ivie, read our paper and check out our implementation on GitHub.